Welcome to Mackey Study Circle channel. In this video, we shall see how to do the computer drafting of the orthographic projection of planes. Coming to the problem statement, a triangular plane lamina of sides 25 mm is resting on HP with one of its corners touching it such that the side opposite to the corner on which it rests is 15 mm above HP and makes an angle of 30 degrees with VP. Draw the top and front views of the lamina in this position. Also determine its inclination with HP. So looking at the problem statement, we can understand that a triangular plane lamina which is having the side length equal to 25 mm. So we'll assume that to be an equilateral triangular lamina and it is resting on HP on one of its corners. Okay. And also he tells that the corners such that the side opposite to that corner is 15 mm above HP. For example, if I tell that a triangular lamina is resting on one of its corner, say A, okay, the side opposite to that will be BC, and that side BC is at a distance of 15 mm above HP. And it also makes an angle of 30 degrees with VP. That means what? The angle, the side opposite to that corner also makes an angle of 30 degrees with VP. Draw the top and front views of the lamina in this position, and we need to determine the inclination of the lamina with HP. So here the inclination with respect to the VP is given. However, the inclination with respect to the HP is not given. So we will execute the solution for this problem statement by drawing the XY line of any arbitrary length of thickness 0.18 mm. We will annotate the line to be X and Y. The plane above the reference line is VP and the plane below the reference line is HP. So this is the annotation of the reference line and the principal planes. So now we will try to draw the top view of the triangle. So since it is resting on one of its corners on the HP, so we will take the side which is 25 and then we will try to construct the triangle. So all the sides will be equal. So this is the triangle plane which is resting on one of its corner. So towards the right hand side of the observer, the corner is visible. So let us annotate this triangle as A, B, and C. So these are the three corners of the triangle. So now we will draw the front view of this triangular plane by considering the projection lines passing through the corner A, passing through the corner C from B. So the front view of this triangular plane will be a straight line. So we will depict that with a thick line having the thickness equal to 0.50 mm. So this is the front view of the triangular lamina. So we'll annotate this, which is A dash and B dash is visible, C dash is not visible, so inside the bracket. So this is the front view of the triangular lamina. So now looking at the problem statement, it clearly tells that the side opposite to the corner on which it is resting. So it is resting on the corner A and the side opposite to this corner is CB. So this corner CB is at a distance of 15 mm from the HP. So we will try to offset this reference line for reference. So this is the line to be offset to a distance of 15 mm from the HP. So it is asking the direction. So it is in this direction. So we will just change the thickness of this line to 0.13 mm. So he tells that this side BC is on this particular line. So how do we do that? We will just try to measure this. So this is 25 mm and this is 21.65. So we will just consider this arc by center point. So we will take any arbitrary point and try to sweep an arc of radius 21.6y from this reference point such that it is going to cut this the offset line. So we will just go for the arc by center point and try to cut an arc of length 21.65. So we'll take the line option, and since it is the front view, it should be a continuous line of thickness 0.50. So from the point of intersection, we will try to meet it at the center of the arc. So this is the length of the arc, which is 21.65. So this is one method, or the other method is, after having done the offset of the xy line, what we can do is we can select this front view along with the annotations and select the move option, keeping the copy on. So keeping point A as the reference, I will just move it to one more side of the xy line, and then using the rotate option, keeping the first point of rotation as A and the second point of rotation as B. I'll just try to sweep this so that the end point is lying on this line that is offset. We can just see that it is cutting the line which is at a height of 15 mm. So now we will take this line option and draw the vertical projector downwards. So you have to use your zoom in and zoom out options generously to check if it is exactly on the xy line. So you can just see that this point is not exactly on the xy line. So the best thing is to sweep an arc of this particular radii, that is 21.65. So we'll adopt that method itself. So we'll select arc by center point and then try to sweep an arc of radii 21.65 and then join this point of intersection to the center of the arc. So we will trim this and we will annotate this as B dash, A dash, and this particular point as C dash. And always note that all the annotations pertaining to the front view shall always be above the XY line. So now this is the front view of this triangular plane when one of its edges opposite to the corner on which it is resting is at a distance of 15 mm from the HP. So now we will draw the vertical projectors downwards. So from the point C, I will drop a projector downwards, and then from B and A, it is a common projector line, so I'll drop it downwards. So it has to intersect this point and from A till here. Okay, so there's a small correction. So this is B dash and C dash, and this is corner A dash. So now we will complete the top view of the triangle in its second position. So the point of intersections has to be considered, and then we will annotate this as A, C, and B. So this is the distorted view of the triangular plane when one of its edges opposite the corner on which it is resting is at a height of 15 mm from the HP. So this is the second position. So measuring the angle between this surface of the lamina and the XY line will give us the value of theta, which is 44 degrees. This is the inclination with respect to the HP. So this distance, I can just show it here. Okay. So now we will go on for the next condition. So before we move on to the inclination with respect to the VP, we'll just try to trim this extra projection lines which is not required for us. Okay. So then the second position is ready. So now the same edge is also inclined to VP at an angle of 30 degrees. So we will consider the line option again. Draw a projection line of thickness 0.13 from any arbitrary point on the XY line, but the angle shall be 30 degrees. So minus 150. So when we measure the inclination of this line with respect to the horizontal plane, it is 30 degrees with respect to the VP. So on this line, we have to place this triangle. So I'll select this triangle along with the annotations and then select the move option, ensure the copy is on, and then keeping point C as the reference, I will place the point or the corner C on this 30-degree line and rotate, keeping C as the first point of center and B as the second point of center, and ensuring the copy is off. So I'll rotate. So maybe the 2 points are not selected properly, so that is the reason. First point, second point. So now you can see that the overlapping shows that the line is turning out to be red in color. So this completes the overlapping part. So now we will just try to draw the vertical and the horizontal projectors. So the horizontal projector is already there, the offset line. So now we'll just end up drawing the vertical projectors. So projector from B has to meet the projector here, and projector from C shall meet the projector here, and projector from A shall intersect the XY line because the projector of the corner A is lying on the XY line. So now we will consider the front view of the triangle when it is inclined to the VP at an angle of 60 degrees. So from B to A, A to C, and then C to B will complete the triangle. So this is corner B dash, and this is corner C dash, and this is the corner A dash. So with this we complete the problem. So before we end up, we shall indicate the directions of the projection lines by using the leader option. So this is the direction of the projector line in this direction, and then we have taken the projector upwards in this position and downwards in this position, and then from LHS to RHS, and here also it is upwards. So this is how we indicate the direction of the projection lines. So using the trim option, we can trim this and this part of the offset line so that the projection lines are not making the engineering drawing clumsy. So we will just try to shift the annotations and ensure that they are not overlapped by the projection lines and they are visible clearly to the observer. So as I've told, ensure that all the annotations of the front view are always on the XY line and not below the XY line. So with this, we complete the orthographic projection of a triangular plane lamina resting on one of its corners on the HP. And the side opposite to that corner is at a distance of 15 mm from the HP, and the same edge is also inclined to VP at an angle of 30 degrees. So this completes the problem. Thank you all for watching.